Hello and welcome to this MicroTasker Shorts video in which I'll be showing you how to build the MicroTasker project in IAR Embedded Workbench. The first thing I do is I browse to the MicroTasker project directory, and in its application MicroTasker v1.4 I locate the IAR 8 i.MX RT directory. Inside of this folder I can double click on the Embedded Workbench project to start IAR. Once the main project is open, we see that we have three sub-projects. We have the MicroTasker Bootloader, we have the MicroTasker Serial Loader, and we have the MicroTasker v1.4 application. So now I'm going to show you how to build the Bootloader project and an application. The first thing we do is we go into the Tools directory and we select Configure Custom Argument Variables. This will open up the variables used by the MicroTasker project, where we will see that we have the target board and then we have some keys. A very quick explanation: the target board is obviously the board and the processor we want to build for. The magic number value is a simple project check that new upload files do belong to the project which we're using. And then we have the authentication value, which is used to authenticate that upload files are coming from a validated source. When we use encryption, this is our AES 256 key. It's also used as an AES 128 key when we use on-the-fly decoding. And this is the corresponding initial vector to go with the keys. In the bootloader options, I verify that we have the correct processor selected. If not, I modify this to the one that we want to use. And now I can build the MicroTasker bare minimum bootloader. I can take a look at the output directory where the object is located to, and here I find that we have the binary file MicroTasker boot, then with the name of our target. This is not loaded directly to the board, but instead is used as input to the following step. So now I switch to my serial bootloader and I choose its fallback loader target. Again, I'm checking the options to make sure I have the right processor selected, and then I can build the project. I now find in my output directory two files, one called MicroTasker fallback loader image and the name of the device, and the second one as a hex file. Now this could be loaded to the board. It contains the bare minimum bootloader combined with an encrypted version of the fallback loader. The hex file is mainly used by TNZ4 users because that is the loading format which they require. Back in IAR Workbench, I select my next step, which is to build the serial loader. I now start the build. I now find in my output directory some more files. I find the MicroTasker serial loader upload file. This is the file which I could now upload to the fallback bootloader if I wanted to, or I can use the MicroTasker bootloader image, which is already a combined file containing the bare minimum bootloader, the fallback bootloader, and the serial bootloader, again in hex format for TNZ4 users. Normally these first three builds would only need to be performed once, because now we have the bootloader ready for operation, so we can turn our attention to an application. In the application project, I also have several target options. I have the standalone target. This I won't show because it's not particularly interesting. It doesn't use bootloaders, so it cannot be updated and so on. I have the ITC target, which will be built to run in internal memory, which is the fastest operation. And I have the XiP version. The XiP version is an uploadable version, but it stays in QSPI flash and it runs from there. I'm going to select the ITC target, and again I'm going to check that we have the right processor. So now I can start building the application. Where we will see that we have some binary and hex files again. First of all, we have an uploadable form, which is AES-256 encrypted as a binary file and also in sRecord version in case the installed serial loader accepts sRecord loading. And then we have a MicroTasker complete image. The complete image is a combination of the bare minimum bootloader, the fallback bootloader, the serial loader, and this application. This is very useful because in production environments, this could be loaded to the board so that everything is included in a single step. Again, we have a hex version for Teamsy 4 users. Back in Embedded Workbench, I now select the final application build that I'd like to show you, which is the XiP build, execute in place. So I've started the build. And now we find two additional files. The first binary file is an in-place binary which can be uploaded to the serial loader. This is plain code without any encryption. The second output is in AES-128 encrypted format, which is then suitable for on-the-fly decryption. Now, when this version is uploaded to the serial loader will recognize that its content is encrypted, and it will automatically enable either the BEE encryption, which is the bus encryption engine, which is used in most of the i.MX RT parts, or it will activate the OT-FAD decryption, which is used in the 1011 part. This video has thus shown that it's fairly simple to build the MicroTasker bootloader, which is normally only performed once, and then the applications which are automatically suitable for uploading to the serial loader in either a plain text form or with the on-the-fly encryption form without any extra work being required.